Welcome to Chemistry Wide. Today we will see chirality in compounds nitrogen and sulphur. Note, chirality means asymmetric carbons. Chirality means non-superimposable mirror image. If carbon has 4 different substituents, it is called asymmetric carbon. First we will see nitrogen. If nitrogen has 3 different substituents, it is called asymmetric nitrogen, because nitrogen it makes 3 bonds only. For example, tertiary amine, there is one methyl group, another methyl group, another methyl group. This nitrogen attained 2 electron, 1 lone pair electron. This nitrogen has sp3 hybridized. This nitrogen is chiral because 3 different group around it. We can write this molecule below like, see below. We can write like this. If we tell this is dextrorotatory, it is mirror image is going to blow. If we tell this is dextrorotatory, it is mirror image is going to blow like this. This is going to opposite side. This is levorotatory. This is dextro. It is going to mirror images. We get this image levorotatory. This is the D. This is the L. The mirror. See, this is not enantiomers. Now we can use new terms. This both are is not enantiomer. The new terms of enantiomers, because in this interconversion here we need only very low energy. So if start produce the dextro compound, it is going to suddenly changes levo compound. So it is called invertomers, because here we need very low energy like 6 calorie, 6 kilocalorie. Energy diagram for this. This is the energy diagram. This is reactant side, this is product side, this is the energy diagram, this is the transition state. This energy is enough for this reaction. At room temperature, dextro going to change levo. It is enough for room temperature. If we have dextro compound, it is enough to going to levo compound at room temperature. Dextro going to change levo and levo going to change dextro. This interconversion never stop. It is called racemic mixture, because both product we are getting in this process. So we can't separate in this mixture. So this is called invertomers. Here note this, we can't separate in this mixture because this reaction is very fast. The reaction rate is very fast. See below. This is the 109 degree 5. This is the sp3 hybridized nitrogen, because this nitrogen has only one single bond. This nitrogen is pulling the lone pair electron. Pushing the lone pair electron. It means another word is suppressed, because nitrogen make only 3 bonds, but here 4 bonds. 1, 2, 3. Sorry. This nitrogen has 3 bonds only. 1, 2, 3. This is the lone pair. Just like that, in interconversion, it is going to like this. This is dextro and this is levo. 109.5 degree. This is also 109.5 degree. We studied at a valence bond theory. We know that. Please, you remember this term. The lone pair repulsion greater than lone pair bond pair repulsion, and that is greater than bond pair repulsion. See this simplification. When suppressed the lone pair electron, it is going to the lone pair electron suppressed, it is going to 109 107 degree to 108 degree. See below. This is the actual normal molecule. This is the air methyl group. There is another methyl group. This is another methyl group. This is the sp2 hybridized. See below. If trigonal planar bond angle going to 120 degree angle, this interconversion have to occurs. The sp3 hybridized nitrogen going to sp2 state. When suppressed the lone pair electron, the sp3 hybridized nitrogen going to sp2 state and come back again sp3 state, because they suppressed the lone pair electron. This is the main causes. See below. sp3 going to sp2 and sp2 going to sp3 and sp3 going to sp2 and sp2 going to sp3. It is takes place fast rate. Fast rate means fast. This is the very fast reaction. Say if bond angle 108 degree to 120 degree, the difference is 12 degree. 12 is the small amount and it is provides at room temperature. This is the enough for the room temperature for this occurs in the reaction. At room temperature and the interconversion going to be easily. because the band angle difference is only 12 degree. See next, when the nitrogen atom is in 3-membered ring and it is connected to another hetero atom containing lone pair of electron, is optically active. This is optically active. Below the example, this is the cyclic nitrogen 1-amino aziridine. This compound is named 1-amino aziridine. This compound is 1-chloro-2-methyl aziridine. In aziridine, nitrogen is 3-membered ring and it is connected to oxygen. We know nitrogen is a 3-membered ring. It makes only 3 bonds only. See below, see the nitrogen, here oxygen, this is carbon, this is pentyl group, this is pentyl group, this is methyl group, the oxygen, this is the lone pair. So difference between the angular ring strain. 3 members ring system is strained ring. This is more strained ring. So there is possibility for inversion. The standard example, Trojer's base. See the Trojer's base. This is the Trojer's base. This nitrogen is bridgehead nitrogen. This nitrogen is also bridgehead nitrogen. This 2 nitrogen does not going to invert because it is stuck on the centers. So it is produce stable dextro and lever form. Next, sulfur. The chiral sulfur compounds play an important role as catalyst or reagent in asymmetric synthesis. The sulfur is a hexavalent atom. See, this is the chiral and optically active because there is see like this. This is the chiral and optically active. Sulfonium salt. This is the sulfoxide. This is also chiral and optically active. If you any confusion, see the valence electron for the sulfur. So this is the hexavalence. So it is makes only double bonds. So don't confusion here. So this is chiral and optically active. This is also chiral and optically active. This is also chiral and optically active. It is enough for 2 bonds. This is the causes. Sulfones. This is the sulfonium salt. Sulfones, which is also possess sulfur bonds tetrahedrally, do not display chirality due to the presence of 2 oxygen atom and sulfur. but if sulfones contains different of oxygen like oxygen 11 and oxygen 8, they shows chirality. This is the oxygen isotopes. This is the also oxygen isotopes. See below. This the optically active and chiral compound. Sulfur isotopes. There is 4 different group, but we need 2 groups enough for sulfur atom because this is hexavalent atoms. Same thing here. Sorry, this is optically active and chiral sulfone isotopes. Sulfone, not isotopes. Without isotopes of the sulfones, this is not optically active. There is 2 oxygen atom with the same mass number. See the difference between two them. Thanking you all. Please subscribe the channel. More videos on TV. This is my beginning stage. That's why I mistakenly somewhere in the notes. In upcoming videos, I will improve and gives perfectly. Thanking you all the best.